right, so on today's lesson, we are going to be on page 68. This is the start of several days of using this foldable. We are solving quadratic equations, and each of these are the ways that you could use to solve quadratic equations. Now, the solutions of a quadratic equation is the value of x when you set the equation equal to 0. It's where you cross the x-axis. You need to know all of these words right here. Solutions, roots, zeros, and x-intercepts all mean the same thing. So if I ask you to find the solutions, you'll use one of these methods. If I say, what are the roots? You're looking for using one of these methods because you're finding where it crosses the x-axis. Now, how do we know that we have a quadratic equation? What's every quadratic equation have? Well, the vertex will, it has the square. All right, so to be quadratic, the highest term, so I want you to remind yourself of this. The highest term is x to the second power. And what does a quadratic look like?
It looks like f of x,
That's how you start it. Though it makes a u when you graph it. All of your equations are going to start with either f of x equals or y equals. Okay? Now, let's open this up. We're going to open up the part that talks about graphing. Okay? So, open up, solve by graphing. To solve by graphing, you need to understand that the solutions are the x-intercepts. All you got to do is find the x-intercepts. I want you to write that up here. Find the x-intercepts. If I give you a graph and ask you for the solutions, the roots, or the zeros, you are looking for the x-intercepts. And where am I going to find an x-intercept?
where it crosses the x-axis.
Where it crosses the x-axis. Okay? So on this top equation, now this is the formula, the function I mean, for this particular parabola. And this parabola, when I copied it, I really should have put arrows there. Why? Because it keeps going. Now, this is my x-axis. The solutions are where we cross the x-axis. So I have a solution right here and right here.
So that's 2 and negative 3.
Very good. Your answer, you're finding what x equals. So your answer is going to look like this. X equals. Okay, what are those two solutions?
Negative 3 and 2.
Negative 3 and 2.
But can you we put 2 and negative 3?
You can switch it around. 2 and negative 3. I'm okay if you do x equals negative 3 comma 2. But what can you absolutely not put? You can't put parentheses because if you write, don't write this, but if you write this, you're telling me that your solution is negative 3, 2, and that point would not even be on your graph. So if I give you a graph and tell you to solve it, what are you looking for? Your x-intercepts. So let's look at this one. I'm looking right here at g of x. All right, that should really have arrows. If I need to know what x equals, I need to find the x-axis. Now, this is your horizontal. This is actually your x-axis right here. Okay? It's kind of a fuzzy graph, but that is your x-axis. I love that you noticed that. It doesn't cross it. So, what does that mean? Are you ever going to have a solution? No.
That is your answer.
So, your answer is there is no solution. Now, if you tell me that you have 0, that would mean you cross where x is 0. And do you cross there? No. So, because it does not cross the x-axis, you have no solution at all. All right? This one. I need my arrows. I should have drawn those. My bad. I'm looking for my solutions, my zeros, my roots. All of that means I'm looking at the graph and I'm looking for the x-intercepts. Does this graph have an x-intercept?
Yes, it does.
It does, right here. Now, it touches Therefore, that's an x-intercept. So how many solutions does this have?
One solution.
Just the one, and tell me what that x value is. That x value is 1. So, you've seen with these 3 examples, you could have one solution if the vertex is sitting on the x-axis. You could have no solutions if it doesn't cross the x-axis. Or you could have 2 solutions. All right? Now, the reason you write x equals is because that is the number that if you plug that in, the y value would equal 0, which means it's sitting on the x-axis. All right, so that's solving by graphing. If I gave you a quiz, a pop quiz on solving by graphing, how would you do?
Well,
You'd fail.
I'm graphing. What?
What is all you'd pass that sucker? Why?
You're looking for the x, or just the x.
You're looking for the x-intercepts, okay? All right, so let's solve with taking the square root. Yes, friend?
Okay, say on number, or on the third graph.
On H.
It was like, almost, like, if it just barely touched it, what would that be?
If it's touching it, it's touching it.
What was in the middle of the line right here, where, what's that one is?
Uh-huh. If it was like right here,
No.
or it was right here,
Right here.
you wouldn't be able, you would have to use a method called quadratic formula if it's going to cross at like a decimal, because you can't look at it and see. If I give you one on a graph and say, what is this? It's going to cross perfect at 2 grid lines.
Okay.
All right?
So the deal would never be one just like in the middle.
Yeah, when you're looking at them, it's not going to be there. Now, a graph could cross in the middle, but you'll use what's called the quadratic formula to solve it. All right, now, the next thing that I want you to do is I want you to look at the steps. You're going to only use this if you have just an x squared. You notice how you don't have like the x to go with it? All right. You're going to get the squared term by itself. You're going to take the square root of both sides. Now, you cannot take the square root of a negative number yet. You'll learn that in advanced algebra. When you take the square root, you always get 2 numbers, a positive and a negative. Here's why. Okay? You don't have to write this down. Just look and think with me. What number times itself can give you 25?
5 and 7, but that 5 and 5.
5 times 5. Now, what if I tell you there is another number that times itself also gives you positive 25?
Oh.
Nope, got to be the same number.
5 squared?
5 and 5, which is 5 squared.
Hang on. Give me that. Hang on.
Negative times a negative becomes a positive. So if I said to you, what's the square root of 9?
That's 3 squared.
Okay, so it's 3, because 3 times 3 gives you 9, but guess what? It's also negative 3. So, because negative 3 times negative 3 gives you 9. Now, let me show you the way that we write this. You have a positive 3 and a negative 3. You can write this as plus minus 3. What do you think that means?
That means
A positive 3 and a negative 3. Okay? All right. So, let's look at this. Now, I see, you're listening, I see only an x squared term. I want to get the x squared term by itself. How do I get rid of minus 16? You're going to plus 16. So we're thinking about solving equations from back, like months ago. You've got x squared equals 16. Now, you have x squared. You want x by itself. So you're going to unsquare this by taking the square root of both sides. What you do to one side, you do to the other. Because the square and the square root, they cancel each other out because x times x gives you x squared. So you get x equals. Automatically, when you take the square root of a number, you know I could get a plus and a minus. And what is the square root of 16? 4. So your answer, your x-intercepts, would be at positive 4 and negative 4. So what you're trying to do when you take the square root is you can only have x squared. You can't have an x term. And you're getting it completely by itself. So let's look at number 3. I know I'm skipping around, but I'm doing it on purpose. I have x squared minus 24 minus 12. What part do I want by itself? I want the x squared by itself, so I got to move the 24. What is the inverse of a negative 24? All right, so let me add 24.
You get x, you can put a little house thing.
All right, well, hold on. I get x squared equals 12 and 24 is 36. Now, you're supposed to be solving for x and have x equals number. You don't have x equals because what do you have? X squared equals. You're going to unsquare by taking the square root. And what you do to one side, you have to do to the other. Now, a square and a square root cancel. When you take the square root of a number, what did we figure out while ago?
You get a plus and negative.
Very
You
good.
get 6.
Very good. So they are exact opposites. One's a positive and one's a negative. You can't tell the vertex from this one because this is not a vertex form.
No, what it's giving you is where it's going to cross the x-axis.
No, because all you have is an x. You don't have a y at all. You're solving an equation. All right, let's look at 2. I need this x squared by itself. So the first thing I got to get rid of is any add or subtract. How do I get rid of subtract 50?
Plus 50.
All right.
And you get 50 there.
So I got 2x squared equals 0 plus 50 is 50. Now, I can't take the square root yet
No,
because x squared is not by itself.
so you
What's
got-
over here with x squared?
You got 2
Times 2. So how do you undo times 2?
You gonna divide by 2.
All right, I agree. So 2 divided by 2 gives me x squared. 50 divided by 2 is 25. Now, if you stop right here, you're wrong. Because you don't have x equals, you've got x squared. How do I undo square?
You gonna you put house and
I'm going to take that little square root, okay? Now, when I'm solving and I take the square root of a number, I can get one positive and one negative of that number. What's the square root of 25?
5.
5. So that, if I was to put this on, turn this into a function and put it on the graph, your x-intercepts would be positive 5 and negative 5. That's where it would cross. Now, 4 looks weird. Why does 4 look weird?
Because it's got an x plus 2.
It's got an x plus 2 squared. So what's getting squared is this whole part. I need that part by itself. So plus 4's got to go. How do you get rid of plus 4? I mean minus 4. You're going to add 4. You're right. I said the wrong thing. You were right. All right, bring this down. X plus 2 squared equals 12 plus 4 is 16. Now, the part that is being squared, I have it by itself. How do I unsquare what is under my finger?
You on the divide?
No.
No.
You're going to put the house. You're going to take the square root. Now, what happens with a square and a square root? They cancel each other out. And you free up whatever is under my finger, which is x plus 2. So you're going to bring down x plus 2. You're going to work this out. When you take the square root of 16, what do you get? A plus and a minus 4. Now, you're not done until x is by itself. Is x by itself? Why not? You got a plus 2. You're going to minus 2. Now I want you to watch this. This looks crazy. You're going to do x equals. I'm going to write negative 2 plus and minus 4 because there's a positive 4 and there's a minus 4. I've got 2 answers. One answer is going to be from doing negative 2 plus 4, which is what? 2, okay? The other answer is going to be from doing negative 2 minus 4, which is, nope, Negative 2 minus 4. Negative 6, because you're going to get bigger. So what are your two answers?
Them right here.
2 and negative 6. Now, let's be honest. Do we think this happens a whole lot? No. Most of the time, you're going to be dealing with ones like this. The only time that you can use solve by taking the square root is if all you have is an x squared term. If you had x squared minus 24x equals 12, you can't solve like that. You can only solve by taking the square root if you have x squared term. Now, real quick, what if I give you a graph? How do you find the solutions?
You trying to find the x.
You're trying to find the x-intercepts. If you have multiple x-intercepts, you could either have 1, 2, or none. Can you write this in a parentheses? Why? Because it's not a point, it's two separate points. Okay? So tomorrow, we're going to keep working with these other ones.